When we look up at the stars, it may seem as if the universe is silent, but that's not true. Space is not empty. It is full of stories. Some of them are well known. We know about the sun, the moon, and the 9, or is it 8, planets. But beyond textbooks and popular films lies something more. Where familiar explanations fade, the true mystery begins. The cosmos holds thousands of secrets that are rarely spoken of. Facts that could change our understanding of the universe and of ourselves. Why does glass rain fall in certain corners of the galaxy? What happens inside stars that cannot die? And how can a nebula, millions of light years away, influence the rhythm of our hearts? Today, we'll set out into this strange and beautiful expanse, into the shadow of the great silence, into the place where little-known facts become keys to something greater than knowledge alone. Sometimes, it feels like science isn't entered by ordinary scientists, but by figures of myth. One such figure was Fred Hoyle, a man who seemed to embody 3 destinies at once. His name was spoken with respect, sometimes almost in the same breath as Einstein's. Yet he was also a darling of the press, tossing sharp ideas to journalists with ease. He was a provocateur whose theories stirred the imagination, even if they didn't always serve science. At times, he didn't seem like a scientist at all, but a writer, a philosopher, ceaselessly scattering paradoxes, as though he drew more inspiration from literature than formulas. One man and 3 versions of Hoyle, the scientific classic, the jester, and perhaps the prophet. He entered history as one of the greatest astronomers of the 20th century. His discoveries shook science and sparked a revolution in our understanding of stars. At the same time, he was often seen as one of the most unusual scientists of his era. His ideas ranged from brilliant to seemingly absurd. At times, he resembled a theory-producing machine, a printer indifferent to content, so long as the output was striking. Fred Hoyle seemed to delight in the creative process itself, unconcerned with how his colleagues would respond. He created scientific truths and scientific myths with equal passion. One of his most foundational works was on thermonuclear fusion in the cores of stars, written in collaboration with Margaret and Geoffrey Burbidge and William Fowler. Before that, scientists didn't understand where all the chemical elements that make up our world had come from. The Big Bang, according to modern theories, had created only hydrogen and helium, the 2 lightest elements. So how did everything else come to be? Hoyle and his colleagues explained, it is in stars and their burning hearts that heavier elements are forged from hydrogen, carbon, oxygen, iron. The great alchemy of the universe finally had a scientific explanation. But just as impressive as his success was his defeat. In the mid-20th century, science embraced the idea of an expanding universe. All evidence pointed to it once being incredibly dense and small, the size of the so-called primeval atom. But Hoyle, a proponent of a different concept, sharply rejected the Big Bang theory. Mockingly, during a live BBC broadcast, he called it the Big Bang. The phrase stuck. The dismissive term unexpectedly became a brand. And although Hoyle rejected the model, it was he who gave it the immortal name. He offered an alternative. The universe is eternal, without a beginning, and constantly expanding. But in doing so, it generates new matter to maintain constant density. Thus, between the galaxies flying apart, new ones emerge to refill the cosmic void. It was a beautiful idea, logically coherent, but unconfirmed by experiment. Most scientists abandoned it after 1965, when cosmic microwave background radiation was discovered, a key prediction of the Big Bang theory and its crowning triumph. Another of Hoyle's passions was the origin of life. If the universe is eternal, then perhaps life is an inherent part of it as well. In the 1970s, riding the wave of space exploration, Hoyle and Chandra Wickramasinghe revived the hypothesis of panspermia, the idea that life is transferred between celestial bodies. In their view, the cosmos is literally teeming with life. Microscopic organisms travel on meteorites, in dust, gliding freely through interstellar space. When they land in a suitable environment, these spores awaken and transform, dead worlds into thriving ones. The spectra of cosmic dust, in fact, did resemble the spectra of organic matter, especially that of dried bacteria. Hoyle and Wickramasinghe made a bold proposal. Spores might even travel between galaxies. In the Milky Way alone, they estimated, there could be up to 10 tons of spores. According to their theory, the universe is filled with a kind of microscopic airborne fleet, dropping landings on every piece of solid matter. Moreover, they suggested that some diseases like the plague, HIV, or mad cow disease might have been brought from space. Here, the boundary between hypothesis and science fiction begins to blur, and the scientist transforms into a novelist. Hoyle did, in fact, write novels. In one of them, The Black Cloud, he imagined an alien intelligence in the form of a giant cloud, a gaseous organism traveling across the galaxy. Perhaps such beings already surround us. We just don't know how to recognize them. He provoked admiration and irritation, inspired and confused. Some called his ideas heresy, others revelation. Perhaps they will become truths tomorrow, even if they seem like fantasies today. And yet, within these images, these ideas, lies a deep human dream, not to be alone in the universe. That dream lived in poetry, philosophy, and myth. Sometimes it comforted us, sometimes it frightened us. In one scenario, aliens help us unlock the greatest secrets. In another, they destroy us in a struggle for the stars. Immanuel Kant believed that all planets in the solar system were inhabited by intelligence, and that the farther from the sun, the greater the intellect. Biochemist Christian de Duve considered life a cosmic inevitability. Molecular biologist Jacques Monod, on the contrary, believed that life on Earth is an exception, a freak occurrence in an indifferent universe. Astronomers are also divided. Some claim the cosmos is full of life. Others find so many limitations that Earth, in their view, is a lonely island in a boundless void. And yet, we keep searching. Though there is still no proof, no organisms, no artifacts, not even traces of vanished civilizations, we now have a plan. The first direction is the solar system. On Mars and on the icy moons of Jupiter and Saturn, scientists believe microscopic life might be possible. The second, exoplanets. Since the discovery of the first planet outside our solar system, their number has grown to thousands. Some of them resemble Earth, and in the coming decades, new telescopes will allow us to study the composition of their atmospheres. But the most thrilling is the third front. The dream of scientists will truly come to life only when we discover not just life, but intelligence. The lead actor who steps onto the stage after the third bell dot, is that even possible? In our galaxy alone, according to estimates by astronomers Peter Baruzzi and James Peebles, there may be up to 1 billion Earth-like planets and up to 10 billion giant gas worlds. And 80% of them are far older than our solar system. Hundreds of millions of years of head start for a potential civilization. And so, scientists still hold on to hope. Perhaps, somewhere out there on another star, in another system, someone is looking up at the night sky with the same question. Almost 10, that's the probability, according to astrophysicist Adam Frank from the University of Rochester, of a technological civilization arising in the observable universe. A number that sounds almost like abstraction. But think, even our own star, the Sun, has nearly a dozen planets orbiting it. Now, imagine how many other stars there are in the universe. Billions, trillions. The chance that we are truly alone comes out to about 1 in 10 squared. We don't have a definitive answer to whether life exists in the universe. But that number, so unnaturally small, seems to whisper, no, you are not alone. And if we consider not the entire universe, but only our own galaxy, the Milky Way, even the most skeptical researchers begin to acknowledge the possibility of other intelligent forms. A few years ago, American scientists, astronomer Michael Hart and physicist Frank Kepler proposed a hypothesis. Perhaps we are the only civilization in the Milky Way. But even then, they had to admit that in other galaxies, at least a few inhabited worlds must exist. And perhaps, beyond the horizon of space and time, other technologies have emerged, other histories, other hopes. Still, the space between these island stars is so vast that civilizations could exist without ever knowing about each other. And yet, here and now, can we detect even a shadow of extraterrestrial life? Ever since humanity invented radio, scientists have wondered, if there is intelligence out there, maybe it would try to reach us, leave a trace. Radio waves are one possible medium for such a dialogue. In 1960, American astronomer Frank Drake began the search. He pointed a meter-wide radio telescope at 2 stars, Tau Ceti and Epsilon Eridani. He hoped to catch a signal, maybe artificial, maybe a message. Since then, dozens of radio telescopes have scanned the skies, listening for anything. So far, nothing. But that doesn't mean there are no signals. It means the task is far more difficult. We don't know where to look. We don't know which frequencies. We don't even know if other civilizations use radio waves at all. Perhaps they communicate in ways entirely unknown to us. Still, hope remains. In 2015, at the initiative of Russian billionaire Yuri Milner, the ambitious Breakthrough Listen program was launched. By 2025, it aims to scan the surroundings of 1 million stars, not only searching for radio signals, but for any signs of technological activity, unnatural radiation, traces of material processing. Now, astronomers have 2 of the largest telescopes in both hemispheres. The Robert C. Byrd Radio Telescope in Green Bank, with a dish over 100 meters wide, and the famous Parkes Telescope in Australia, its antenna measuring 64 meters in diameter. In ways entirely unknown to us. And now, to midday, in the summer of 1950 at the Los Alamos Laboratory, 2 great minds sit at the same table. Edward Teller, the father of the hydrogen bomb, and Nobel Prize laureate Enrico Fermi. They are discussing interstellar travel. Back then, in that era, the topic seemed almost like pure science fiction, although early reports of UFOs were already stirring imaginations. And then, in the midst of the conversation, Fermi asks a simple yet devastatingly precise question. Where are they all? Thus was born the famous Fermi paradox. Its essence is simple. If even one extraterrestrial civilization had reached a technological level sufficient for interstellar travel, it would have taken only a few million years to colonize the entire galaxy. Yet there are no traces of such colonization. The galaxy is empty. We are alone, or is there something wrong with our premises? Supporters of the pessimistic view argue, since no traces have been found so far, then none have ever existed. Civilizations were unable to overcome the distances, or they died out, or they never appeared at all. Because if they had existed, our solar system would have been a colony long ago, or at least an object of their interest. We would have been discovered long ago. According to the hypothesis of physicist John Smart, if even one civilization in the galaxy learned interstellar travel, it would begin systematically colonizing space. By this logic, the systems nearest to the sun should have been settled long ago. We would be witnesses to their presence, or at least find their traces. But if there are no traces, then where are they? Physicist Jason Wright from the University of Pennsylvania proposed, what if they were here? Not now, but in the distant past. Perhaps at one time another civilization emerged in, or visited, our solar system. Maybe they left traces on Earth, not in the form of ships, but for example in altered geochemistry, isotopic ratios, the structure of rocks. Venus? In the past, this planet probably had a climate similar to Earth's, but 500 to 800 million years ago it was engulfed in massive volcanic catastrophes. Its entire surface was flooded with lava, burying any possible traces of life beneath. Mars? Possibly. If colonies were once built there, they are now ruined by time, hidden under layers of dust. Not disappeared, rather preserved like ancient. Ruins? The moon? Another possible candidate. Or perhaps the asteroid belts, or even the distant Kuiper belt. Who knows? Maybe remnants of mines, bases, signaling beacons are waiting there. Warning, do not approach the sun, or summoning those who understand their signals. Perhaps millions of years ago, driven by the same inexplicable thirst for exploration that drives us, alien visitors already came here. We just do not know what they looked like or what they left behind. But the very idea that someone came before us is not so impossible. After all, if we humans had learned to travel between stars, we too would not resist the urge. We would leave markers, beacons, bases. That is what any curious civilization does. Therefore, perhaps somewhere on the moon, on Mars, on asteroids, discoveries await us already, buried under layers of time, but not gone, not disproven, simply not yet found. In the 19th century, astronomers noticed something strange. While carefully observing Mercury, they discovered that its orbit differs from the perfect elliptical trajectory prescribed by Kepler's laws. Mercury, completing an orbit around the Sun, does not return exactly to its starting point. It's perihelion. The closest point to the Sun in its orbit shifts slightly with each revolution, a tiny but persistent drift. How could it be explained? On January 2, 1860, Urbain Le Verrier, the famous French mathematician and one of the discoverers of Neptune, gave a lecture in Paris and proposed a hypothesis. He suggested that between the Sun and Mercury there may hide an unknown planet, or even an entire belt of asteroids, something similar to what lies between Mars and Jupiter. These bodies orbiting so close to the blinding Sun would be practically invisible, observable only during a solar eclipse or in the rare moments when they transit across the Sun's disk. A few months before this lecture, Le Verrier had received a letter from amateur astronomer Edmund Lesker. He claimed that on March 26, 1859, he observed a round dark spot on the Sun's disk and watched it for 75 minutes. It slowly crossed nearly a quarter of the solar circle. Lesker suggested that this was the unknown planet. He even specified the inclination of its orbit. Inspired by this report, Le Verrier began his calculations. He determined that if the object existed, its orbital period would be 19 days and 7 hours, and its distance from the Sun significantly less than that of Mercury. However, such a tiny planet could not explain all of Mercury's orbital anomaly, but perhaps it was the largest fragment among a swarm of smaller bodies encircling the Sun. Le Verrier was captivated by this idea. He named the hypothetical planet Vulcan, after the ancient Roman god of fire, blacksmith of the underworld. The name was chosen not by chance. The mysterious body was imagined to orbit in a fiery ring, almost at the Sun's surface. Other reports soon appeared. Some astronomers began noticing strange spots on the Sun. Their calculations suggested two possible orbital periods, 26 and 38 days. But confirmation was extremely difficult. Observing objects within Mercury's orbit was extraordinarily challenging. The blinding glare of the Sun damaged telescopes, and posed serious risk to eyesight. Any error, and what was thought to be a planet, could be a reflection, a glare, or even a lens flaw. Yet for decades astronomers persevered. They hoped that one day a solar eclipse would reveal a darkened disk and open a clear black sky. Le Verrier appealed to all astronomers in France, and even beyond, to search for Vulcan. But each time, nothing was found. It was not a defeat. Le Verrier remained convinced of Vulcan's existence until the end of his life. Then, in April 1875, what seemed like confirmation came. German astronomer Weber noted a round spot on the sun. According to his calculations, this was precisely when two hypothetical planets should have transited the solar disk, one matching Le Verrier's 19-day candidate, and the other the 38-day period earlier, discovered by Rudolf Wolf. The data matched within a day. Perhaps measurement error. But was this not proof? Next, on July 29, 1878, during another solar eclipse, Professor James Watson from the University of Michigan observed two glowing bodies between Mercury and the Sun. Another American astronomer, Lewis Swift, the one who discovered the Swift-Tuttle comet, saw only one object, but in a different place. It appeared that three Vulcans, if they existed, were positioned around the Sun in entirely different locations. Too many Vulcans for one hypothesis? Solar eclipses continued to occur, but Vulcan never appeared. Gradually, doubts grew. The ghost planet remained elusive. Then came a theory that could explain it all. In 1916, Albert Einstein published his General Theory of Relativity. According to it, space around massive bodies, such as the Sun, is curved. If the Sun were in flat, Euclidean space as previously assumed, Mercury would indeed move improperly. But taking into account the curvature predicted by Einstein, everything fell neatly into place. The strange drift of perihelion amounted precisely to the 43 arcseconds that once prompted Le Verrier to propose the unknown planet. There was no longer any need for Vulcan. It was erased. In May 1929, German astronomer Erwin Freundlich traveled to Sumatra to observe another total solar eclipse. He carefully examined photographic plates and found many stars shining in the daytime sky. But there was not a single planet to be seen. That seemed like the final word. And yet, even after this, several astronomers again reported strange objects near the Sun. One of them, Henry Curtin, insisted he had seen Vulcan. According to his calculations, the mysterious planet orbited the Sun every 20 days at a distance of 0.06 astronomical units, with a diameter between 300 and 800 kilometers. But this finding, too, was never confirmed. What did these observers see? After all, they were not cranks, but serious researchers. Edmund Lesker likely observed an asteroid crossing the Sun's disk. Today, such events are discovered annually. Back then, they were unknown. Perhaps the other astronomers, driven by their dreams, mistook asteroids or stars in the eclipsed sky for planets. Professor Watson, for example, misidentified stars in the constellation Cancer as a planet. Curtin may have seen a bright comet. And sometimes all it took was an optical defect, a dust speck, a scratch on a lens, a fleeting glare. Thus Vulcan, born in the minds of astronomers, faded into oblivion, vanishing like an illusion, a dream, a shadow. Yet it remained in the history of science, as a reminder of how powerful the thirst for discovery can be, and how astonishingly the universe reveals its secrets, often not where we look, but where we never thought to look. Since ancient times, when the stars were closer to myth than to science, popular lore associated Mars with the god of war. Its reddish face, as if stained with blood, seemed to speak of battles forever frozen on its surface. But in the late 19th century, this bloody god suddenly became a messenger of life. In 1877, The Italian astronomer Giovanni Schiaparelli, a man with remarkably sharp eyesight and no less sharp intellect, saw something strange on Mars, the thinnest of lines stretching from one dark patch to another. He called them canali, which in Italian simply means channels. Schiaparelli believed they were natural formations, giant riverbeds connecting mysterious Martian seas and running toward the polar ice caps. But soon another hypothesis emerged. What if these channels were not natural at all? What if intelligent life actually existed on Mars? Some speculated that Martians had dug the canals themselves to carry water from the melting polar ice in summer down to the southern regions irrigating fields cultivated by the planet's industrious inhabitants. Only one fact puzzled even the boldest researchers. If these canals were visible from Earth, they had to be several hundred kilometers wide. Who could possibly construct such colossal works? An answer came from American astronomer Percival Lowell. In 1894, he founded an observatory in Arizona for the sole purpose of studying Mars and its mysterious canals. Lowell claimed that along the canals there were floodplains covered in dense vegetation, clearly distinguishable from the lifeless deserts. In his imagination and in his maps, the canals formed a precise geometric grid, straight lines drawn as if by ruler. Not like our winding rivers, but more like engineered arteries of a civilization. A civilization capable of mastering the forces of an entire planet, not by the early 20th century. Belief in the habitability of Mars had become nearly mainstream science. Not just astronomers, but writers, journalists, readers, people from all walks of life sincerely believed in Martians. The idea that they might be ahead of us in every field, science, technology, the arts, captivated the imagination. The French astronomer Camille Flammarion enthusiastically wrote that Martians had built cities and attained everything there was to attain. During these same years, fantasies about Mars began to infiltrate literature. In 1898, H.G. Wells wrote his famous The War of the Worlds, a saga about Martian invaders, cold, ruthless, utterly alien. In the 1920s, Martians were reimagined as utopian heroes of socialist novels. In Aelita by Alexei Tolstoy, the protagonist journeys to Mars in search of love, ideals, and answers. Then came The Martian Chronicles by Ray Bradbury, the Martian worlds of Isaac Asimov. And out of all these stories was born the iconic image of the little green man, the quintessential 20th century alien, always from Mars. But oddly enough, belief in Martians once led to mass panic. On October 30th, 1938, a radio play aired in the United States, a dramatization of The War of the Worlds. It began like an ordinary program, but then the announcer interrupted with alarming news. A giant cylinder had crashed in New Jersey, and then from the wreckage emerged a creature, massive, tentacled, and behind it more. The broadcast sounded like a live report. For millions of listeners, this wasn't theater. It was real. In panic, people jumped into cars and fled blindly. Some even attempted to take their own lives. Wells, the original author, could hardly have dreamed of such a visceral reaction. But perhaps it was too visceral. The roots of this hysteria lay in points and lines, the mind's deep desire to organize the unfamiliar into familiar forms. Ruler straight lines on maps, dots on photographs, spots in telescopes, it all formed an imagined network of canals, endlessly compelling to the human imagination. Hundreds of observations, thousands of eyes, millions of expectations. And now, we know the canals of Mars were an optical illusion, a mistake of perception. There were no giant rivers, no fertile floodplains, no Martian farmers. Only barren plains, craters, and dust. Yet humanity will keep gazing at the stars. Because even in illusions, in these imagined canals and green-skinned Martians, there lives a longing for wonder, a desire not to be alone in the silent cosmos. And maybe, one day, it won't be fantasy, but a real glance from another world that finally answers us from across the cosmic void. Stanislaw Lem once wrote that Mars is like a mirror in which humanity sees not just another world, but its own imagination. And indeed, those strange channels that seemed to crisscross the Martian surface were seen by many. Then they vanished, becoming a psychological phenomenon that lost the interest of scientists. But still, numerous astronomers sketched those enigmatic lines, and did so in remarkable detail. Chains of craters, deep valleys, canyons. Take the Valles Marineris, for example. It stretches nearly 4,500 kilometers. In places, it's 700 kilometers wide, and its depth ranges from 2 to 7 kilometers. Schiaparelli and his followers may have actually glimpsed this canyon. But by the 1930s, more and more voices argued there are no canals on Mars. It was all a trick of the eyes and the mind. In the following decade, American astronomer Fred Whipple wrote in his book Earth, Moon, and Planets, we are unable to detect any signs of intelligent life on Mars. If someone believes intelligence ever developed there, then he must imagine a being capable of surviving without water, without oxygen, in temperatures colder than the Arctic. The final disillusionment came in 1965. The Mariner 4 probe transmitted the first close-up images of another planet back to Earth. Only 22 photos, but on them, Mars looked barren, harsh, dead, more like the Moon than Earth. No canals, no signs of civilization. It was a blow to everyone who had hoped for life beyond Earth. At one point, there were even calls to remove Mars from the list of priority research targets. But half a century passed, and today, quite the opposite. Politicians and entrepreneurs increasingly speak of humans reaching Mars within this century. And now, let us turn our gaze to the sun, to the place where, according to some economists, crises are born. Of course, external factors influence the economy, but the idea that the entire global economy could be governed by some astronomical phenomenon, now that sounds strange. And yet, it was exactly this hypothesis that British economist William Stanley Jevons put forward, one of the founders of the mathematical school in political economy. For many years, this serious, pedantic professor devoted himself passionately to the study of sunspots. He compared their occurrence with fluctuations in the economic cycle. In 1878, Jevons published an article in Nature in which he argued that sunspots on the sun set in motion an entire chain of events capable of shaking the economy to its foundations. His calculations were meticulous and his logic impeccable, yet he was never able to prove his hypothesis. The theory remained perched on the boundary between science and mysticism. People mocked him. Sunspots? Seriously? But let us consider Jevons's logic. In his model, the economy is like a pendulum. As long as it swings gently to and fro, all is stable. But if something pushes it too hard, a crisis can begin. To Jevons, the economy was a mechanism driven by self-interest, and any perturbation must come from an external push. But where did it come from? He looked at the sky, and one day he realized solar activity alters the weather, and weather, in turn, impacts agriculture. When harvests are poor, prices rise, and with them come worry, panic, a fall in production, and rising unemployment. A sunspot appears, and within a few steps, famine can follow on Earth. It may sound logical. But when Jevons consulted historical records, he discovered a curious discrepancy. According to his calculations, a crisis should have hit England in 1740. Instead, Holland suffered it. Jevons even asked a fellow economist to examine the archives and found no confirmation for his prediction. He revised his approach. It was not the weather per se that was at fault, but grain prices. If they rose especially in agricultural colonies, such as India, disaster would follow. For India was a colony dependent on its harvest, and a crisis there always echoed back to London and the rest of Europe. Thus the scheme seemed complete. By knowing the number of sunspots, one could in his view predict the onset of an economic crisis. Yet even this model faced doubt. Much later, economist Alvin Hansen observed that economic crises are fundamentally psychological. They are born of fear, agitation, panic, a collapse of sentiment. We brighten when the sun shines and grow gloomy when it disappears behind clouds. We drop all we are doing when fatigued and grab at everything when energized. The Russian scientist Alexander Chizevsky went even further. He too studied the influence of solar activity, but focused not on prices, but on the behavior of masses. He proposed that solar flares dictate the timing of major historical events. Wars, revolutions, epidemics, migrations all could be linked to the rhythms of the star that nourishes our planet. And now, let us move to a point where science meets revelation. In the autumn of 1869, an American alchemist and experimenter named Cyrus Teed was struck by a powerful electric shock during one of his experiments. And he saw another world, a world in which the Earth is a hollow sphere. We do not live on its surface, we live inside it. Above us is not infinite sky, but the interior wall of a gigantic sphere. The sky, the sun, the stars, all of this exists inside, as if within an egg. According to his revelation, our Earth is a sphere about 12,000 kilometers in diameter. An atmosphere, a layer of hydrogen, an ether shell. At its center is the sun, a hidden electromagnetic light. We do not see the sun itself, but its reflection. The moon, too, is a reflection. The planets do not exist, only glimmers of light. In his world, light does not travel in straight lines. Only those rays directed exactly toward the center move straight. The rest bend, and the closer to the center, the more they slow down. Even gravity, he claimed, is merely special rays emitted by the sun. Physicists, of course, were furious. But Teed did not relent. He awoke with a revelation and became prophet. He changed his name to Koresh and founded a religious community, the Koreshan Unity. In 1870, the first meeting was held in New York. Then came Chicago, then San Francisco. His apocalypse became faith. His revelation cosmology. Thus the sun, the object that inspired economists and prophets, physicists and dreamers, continued to live on in our theories, fears, and hopes. On one of his missionary journeys to Chicago, he met an inventor, publisher, and surveyor named Ulysses Morrow. No one could quite explain why he carried that title, but he wore it seriously. Morrow joined the Koreshan Unity, and as a man of science, decided to conduct an outstanding experiment. He wanted to prove without question the correctness of Cyrus Teed, who claimed we live not on a convex planetary surface, but inside a vast concave sphere. Morrow designed a giant measuring rod. With it, he could mechanically measure the curvature of the Earth's surface anywhere in the world. He believed that this measurement could tell us the most important thing, whether before us lay an infinite universe, or whether we were trapped inside a hollow ball, doomed to gaze forever at a closed sky, an illusory depth painted with reflections of a single light. The rod consisted of 4 segments, each 3.64 meters long. At their ends were crossbars attached at right angles, allowing precise alignment. The position of each segment could be adjusted with millimeter accuracy. The entire structure, mounted between 2 supports, reached 14.56 meters. To set each support, they dug pits, disassembled the rear section, reassembled it, and the professor recalibrated the whole apparatus. By early May 1897, the device had been relocated some 3.8 kilometers, outreaching the sea. What did the measurements Show? The experimenters declared that they had obtained exactly the result they hoped for. According to them, the sea level rose toward the horizon, and this meant only one thing. They had proven that we do in fact live inside a giant concave sphere. Cyrus Teed's theory, they claimed, was confirmed, but no scientific revolution followed. The academic community rejected the results. Two eccentric individuals, unrecognized by science, conducted their measurements in silence, without witnesses, without peer review. It all appeared as if they sought only faith-based confirmation. And oddly enough, they achieved it brilliantly. The inevitable question arises, was the exercise merely a performance? Not a discovery, but a demonstration of results pre-needed by their sex adherents? Nevertheless, the idea of a concave cosmos did not die. It survived, and though now confined to the darkest corners of the internet, its few believers continue to discuss with fervor how our world is actually arranged. And now about the doctrine of eternal ice. On a summer morning in 1925, all leading scientists across Germany and Austria received identical letters. A storm of outrage swept through universities, laboratories, and libraries. The letter was nothing less than an ultimatum. The time has come. You must choose. Are you with us or against us? While Adolf Hitler cleanses politics, Hans Herberger will cleanse science. The doctrine of eternal ice will become the symbol of the renewal of the German people. Join us now, or it will be too late. The man behind these letters was named Hans Herberger, also spelled Horbiger. He was 65 years old. A long biblical beard made him resemble an angry visionary. And indeed, he was full of rage, because the truth he brought had been rejected. It contradicted everything sacred to official science. And he was certain that everything needed to start anew from a blank page. And on that page, there should be only one name his own. Objective science? No, it was an invention of decadence. A false religion of a degenerate era. Like Hitler, Herberger believed that the essential question was who has the right to know. Only a prophet such as himself could touch the truth. Only his enlightenment could elevate him to a higher level of consciousness. But by the word science, he meant something entirely different from what others understood. Revelations, he asserted, were granted only to him. He possessed no doubt. Even the slightest objection enraged him. Do you trust equations? Do you believe mathematics more than me? How long must you take to realize that mathematics is a contemptible lie? He thundered. But what exactly is the doctrine of eternal ice? Austrian engineer Hans Herberger, who lived from 1860 to 1931, published his doctrine on the eve of the First World War in 1913. It was colorful and mad, like the speech of a deranged prophet. According to this doctrine, millions of years ago, in a distant constellation, there existed a giant planet made of water ice with a metallic core. Upon collision with another celestial body, its icy surface became coated with slag. It did not melt at once, but remained molten inside the glowing star for a long time. Over time, the ice evaporated, and the star's innards scattered across the universe. Light elements were hurled furthest, forming the shimmering Milky Way. From the remnants from frozen water vapor, Herberger claimed our solar system was born, and also an ice belt, the very Milky Way that now lies nearby, barely 3 times farther away than Neptune. He called all these icy fragments ether. They hinder the motion of planets, gradually slowing them down. Small planets grow slower until they cling to larger ones as satellites. And according to his theory, one day they will all fall onto their planetary hosts. Planets themselves gradually spiral toward the sun, to eventually burn in its fire. In Herberger's view, the outer planets Mars, Jupiter, Saturn, Uranus, and Neptune are so-called toids, giant water spheres encased in thick icy crusts. The inner planets Venus and Mercury, which he called helioids, consist mostly of metal. A thin layer of ice coats their surfaces originating when icy needles from the original explosion fell onto them. These needles, as they evaporate, produce sunspots. Their vapor drifts into space and freezes. On Earth, we see it manifest as cirrus clouds. According to Herberger, the Earth occupies a middle position. It is not covered by either thick or thin ice, but the moon is approaching. Allegedly, it will inevitably collapse under its own weight, and its fragments will fall to Earth. Such catastrophes, Herberger claimed, had already occurred several times in history. The last time, when the sixth moon melted and crashed into the planet, the result was the biblical flood around 12,000 years ago. At the same time, Atlantis disappeared along with the former moon. The memory of these catastrophes, he insisted, survived in Germanic myths, in the twilight of the gods, in the apocalypse of John the theologian. It all began with a revelation. According to Herberger himself, one day he was looking at the moon through a telescope, and suddenly realized that its glow was due to it being entirely covered in ice. A few nights later, he received a second revelation in a dream. He saw the universe. A silver pendulum swung, grew larger and larger, and then disintegrated. At that moment, he understood. Newton was wrong. The gravitational pull of the sun, he claimed, does not extend beyond 3 times the distance between the sun and Neptune. To him, the entire universe became a battlefield between fire and ice. In his doctrine, the cosmos was born from a collision. The fiery matter of the sun collided with an icy giant. In 1913, he published his revelations, an almost 800-page volume. As early as 1894, he considered his teaching infallible. Anything that contradicted it was an error. For a long time, his ideas attracted little attention, but after the war, a true frenzy began. The Society of Eternal Ice was founded. Children demanded the cancellation of routine astronomy lessons. Scandinavia. Once Herberger. His theory inspired poets such as Gottfried Benn. Scientists rejected his ideas, but he repeated, all the worse for them. He called himself the only true German genius. Star photographs, forgeries, calculations, lies, equations, a dead end. Either you will learn to believe in me, he said, or you will become my enemy. He did not love to see the Third Reich, but his doctrine inspired its leaders. He was called the Copernicus of the 20th century. Hitler, Himmler, and other criminal leaders supported his ideas. The Anunnab Society, created in 1933 to study the spirit of the Nordic race, adopted the doctrine. A war was approaching between the solar Third Reich and the icy empire of the USSR. The collapse of the Reich also became the collapse of the doctrine. After 1945, it was remembered only in esoteric circles. Star against star the sun. For centuries, people believed that the planets had been created by God. Only in the 10th century did scientific theories appear to explain the distant past of the solar system. The modern theory is based on an idea proposed by Immanuel Kant, a German philosopher of the 18th century, who was the first to suggest that the solar system originated from a cloud of gas and dust. This cloud condensed. At its center, the sun was born. Around it rings, from which the planets formed. Kant's main work, Universal Natural History and Theory of the Heavens, 1755, in which he presented this hypothesis, went unnoticed. It was only nearly a century later that the French astronomer Francois Arago drew attention to it again. Even later, in 1796, the French mathematician and astronomer Pierre-Simon Laplace independently arrived at the same idea. The Kant-Laplace theory became dominant, but in the second half of the 19th century, British physicist James Clerk Maxwell identified its flaws. According to his calculations, the rotation of the material should have prevented the formation of planets. Moreover, it remained unclear why 98% of the angular momentum of the solar system is concentrated in the planets, even though their mass is 750 times less than that of the Sun in 1916. Against the backdrop of war, a new hypothesis emerged, a catastrophic one. According to it, another star approached the Sun, caused powerful tidal waves, and tore off matter from which the planets were formed. But this hypothesis, too, was later rejected. By the 1940s, astronomers explained the distribution of angular momentum by the action of magnetic forces. Thus, the modern theory was formed. The solar system arose from a gas-dust nebula, rich in hydrogen and helium, but also containing water, ammonia, and carbon dioxide. Certain regions of this nebula collapsed, possibly due to shock waves from supernova explosions. These waves passed through the stellar cluster. Over time, the cluster dispersed, and one of its stars became the Sun. Around it, a gas-dust disk formed, stretching for billions of kilometers. Its mass may have been up to 10% of the star's mass. According to scientific estimates, the formation of the solar system was completed about 4.568 billion years ago. The margin of error is only 2 million years. Scientists arrived at this conclusion by studying meteorites whose composition is close to that of the early protoplanetary system. Close to the Sun, in its hot and luminous embrace, lie the rocky planet's terrestrial worlds. These are remnants of material that was not captured by larger bodies. From them emerged smaller celestial wanderers, comets, and asteroids. They have changed very little since the formation of the solar system. Therefore, their study can shed light on the mysteries of its still unresolved origin. In the search for a so-called trans-Plutonian planet, and while studying the abundance of bodies in the Kuiper belt, scientists encountered numerous enigmas. As early as 1846, with a mere stroke of the pen, the planet Neptune was discovered. It lay beyond the orbit of Uranus, yet its observed path did not match predictions. These discrepancies could only be explained by the gravitational pull of an unseen planet X. That was the name given to it by one of the chief enthusiasts of the search, American astronomer Percival Lowell. From 1905 until his death, he methodically monitored the heavens, convinced that a distant, faint planet must exist. For this purpose, he commissioned a specialized photographic telescope, the ASTROGRAPH. Only 14 years after his death, on February 18, 1930, his young colleague Clyde Tombaugh discovered the 9th planet. On a photographic plate, it appeared as a dim 15th magnitude star in the constellation Gemini. For months he photographed the same portion of the sky every night, and even during the day, then manually inspected hundreds of stars, comparing them for the slightest shifts. The newly discovered planet lay closer to the Sun than Lowell had anticipated, and its orbit was noticeably inclined compared to those of the other planets. It was later named Pluto, after the Greek god of the underworld. Ruler of eternal twilight, Pluto took the throne. Yet something was off even in Pluto's domain. It turned out to be too small to cause the observed deviations in Neptune's orbit. This implied that beyond Pluto, there could be other bodies perhaps, even one or more unknown planets. During the era of astronomical discovery by the pen's tip, scientists calculated the possible mass of the mysterious planet that might explain anomalies in Uranus's and Neptune's motion. However, it was never found. Calculations suggested that it would rarely approach the rest of the solar system. Its orbit was too elongated. It seemed to have vanished from detection, receding and exerting no influence. Some even called it Proserpina, after the Roman goddess of the shadowy realm. Clyde Tombaugh continued the search for a 10th planet for 13 more years. Over that time, he examined 45 million objects, and they were all stars. The idea emerged. Perhaps Pluto's orbit should be considered the outer boundary of the solar system. Yet some scientists disagreed. From 1957, American astronomer Henry L. Jeekles continued the search for trans-Plutonian bodies. The work extended over 18 years. Only in the 1980s, after the Voyager 2 flyby, were the masses of the distant giant planets refined. It became clear that previous calculations contained errors, and the supposed anomalies in the trajectories disappeared. Since then, it has been understood that beyond Pluto lie no planets, but only asteroids and comets. If earlier new planets were added to the solar family with a stroke of a pen, now that same pen had to be used to cross them out. Yet the mysteries of the distant regions of our system remain. Pluto itself remained enigmatic, less known than some stars. It soon became clear that beyond Neptune orbit myriad minor bodies. In addition to Pluto and its moon Charon, a new minor planet 1992, QB, was discovered in August 1992. It measured approximately 200 kilometers in diameter and followed an almost circular orbit dot in 1993. Additional asteroids were discovered on the margins of the solar system. Since then, discoveries have followed, one after another. Pluto appeared as but the brightest member of the extensive family of minor planets comprising the so-called Kuiper belt II, more distant ring of asteroid-like bodies. Today, about 500 such objects are known. The belt begins immediately beyond Neptune's orbit, and, it is estimated, may extend to between 100 and 150 astronomical units from the Sun. It likely serves as the source of short-period comets. In 2005, the discovery of a new planet Eris was announced. It was found to be comparable in size to Pluto, with a diameter only slightly smaller. This discovery proved pivotal. Scientists re-evaluated Pluto's status, reclassifying it and similar bodies apart from the true planets. As a result, Pluto and several others were removed from the list of major solar system planets. Only 8 remain. Nevertheless, astronomers do not dismiss the existence of a mysterious 9th planet. The search continues. It may yet exist hidden, solitary, traversing an elongated path on the edge of the solar system. This hypothetical planet is referred to by various names: the ghost planet, the quiet planet. It does not perturb asteroid orbits, remains invisible to telescopes, and evades spacecraft detection. Its orbit, by calculations, must be strongly inclined to the ecliptic. But it is unlikely to be a brown dwarf or a hidden companion star such. Objects would already have been discovered. Perhaps it should more aptly be called a trans-Kuiperian rather than trans-Plutonian planet. In 2016, American astronomers Konstantin Batygin and Michael E. Brown hypothesized that its mass must exceed Earth's by at least a factor of 10, and its orbital period could reach 20,000 years. It might lie roughly 600 times farther from the Sun than Earth. That is, sunlight would take 3.5 days to reach it. The story of this planet is a completely different one now. It may remain myth or become a future fact. Astronomy is a science that has competed with astrology for centuries. While astrology remains the most popular of pseudosciences, its main tenets have long been disproven. Numerous studies in various countries have shown that the position of the Sun in the zodiac at birth has no influence on personality. For example, French statistician Michel Gauquelin studied birth data for 41,000 Europeans, including 16,000 notable individuals. He correlated their personality types and professions with the positions of planets and stars at birth and concluded there is no connection. Neither zodiac sign nor planetary placement nor astrological aspects exert influence and yet astrology long held an important role. It advised kings and generals, helping to select moments for war or peace. People sought omens in the stars, as though they were dice mid-roll. Astrology emerged in an era when people believed human destiny was determined by the whims of gods. And if gods descended from the heavens, then perhaps they once sent signals starshine, the motion of planets. We know that in ancient Babylon, Egypt, and possibly earlier in cultures whose writings have been lost, astronomy existed alongside astrology. As a kind of younger sister, it performed supporting roles, observing, calculating, recording. Astrology attempted to interpret what was observed. It linked celestial phenomena with earthly events, inventing patterns where only chance existed. From the scientific point of view, astrology in antiquity was not superstitious, but a proto-science. It used forms of reasoning akin to scientific analysis, cause and effect, inference, conclusions. German philosopher Ernst Cassirer wrote nearly a century ago that astrology employed reasoning similar to science, only it lacked precise instruments. And yet the stars continued to inspire. Astronomy endured, and the starlight still beckons us forward. Astrology. For centuries, it relied on an ancient, almost instinctive belief that celestial bodies, the moon, sun, stars, and planets exerted some kind of influence on earthly life. This idea seemed so natural that it was seldom questioned. To grasp the hidden power of the stars, astrologers resorted to mathematics, seeking precise patterns in celestial phenomena. Indeed, everything hinged on timing. The moment of birth, the instant of an eclipse, the hour of a battle or coronation. Thus, after many years of observing the sky, they compiled tables, exact positions of celestial bodies at specific times. These were maps of cosmic currents, attempts to read the fate of the world in the movements of the heavens. Using geometry, they plotted planetary orbits, derived formulas, and in doing so, laid the foundation of the future science called astronomy. History of astrology in Europe was complex, at times inspired and radiant, at others suppressed by prohibition and condemnation. The ancient Greeks adopted the zodiac signs and the basics of horoscopes from the Babylonians. In the 2nd to 3rd centuries BCE appeared the enigmatic emerald tablet attributed to Hermes Trismegistus. It contained the famous maxim, "That which is above is like to that which is beneath," implying that stars and earth mirrored one another. However, with the advent of Christianity in the Roman Empire, astrology fell under official ban. In 364 CE, the Council of Laodicea decreed that clergy should not act as magicians, sorcerers, or astrologers, as such practices were believed to undermine faith in God. Yet astrology did not vanish. It survived thanks to its ambiguity. It stood too close to astronomy, the science of celestial bodies. By the 7th century, scientific astronomy flourished in Byzantium. Later, during the Middle Ages, under the name astronomy, it entered schools. By the 10th century, educational institutions open to more than monks were teaching the 7 liberal arts, divided into the trivium and quadrivium. The trivium included grammar, rhetoric, and dialectic. The quadrivium comprised arithmetic, geometry, music, and astronomy. However, geometry was essentially geography, and astronomy was astrology in disguise. The Renaissance brought renewed interest in all things ancient, including horoscopes. Astrology regained popularity. In Schiller's famous tragedy Wallenstein's Death, the great commander gazes eagerly at the stars, seeking his fate. Yet the play's title hints that the stars deceived him. Instead of triumph, he found death. The spirit of the times had changed. Schiller belonged to the Enlightenment, the age of skepticism and irony. The people of this new era rejected the ancient art as naive and outdated. They asked, Is there any physical link between the positions of stars and human destinies? Nevertheless, over the centuries, astrology repeatedly resurfaced. During the 19th century's vogue for theosophy, occultism, and spiritualism, it became fashionable again. And in the 1960s, amid a renewed interest in mysticism and self-discovery, horoscopes became nearly a daily habit. Many read them lightly, yet occasionally, almost miraculously, the random advice seemed uncannily accurate. Scientists called this the confirmation bias effect, yet doubts persisted. Consider, for example, a passage from a Cerdan's expanding the boundaries of the universe. He recalls Johannes Kepler's warning, "In discarding the worthless, do not throw out the baby with the bathwater." The search continues, but so far, in that bath of predictive astrology, no baby has been found. Only murky water. Kepler himself did cast horoscopes cautiously and reservedly. He warned that if an astrologer predicts a person's fate without considering their soul, intellect, appearance, and character, then they are merely guessing. Can astrology truly be called a science? Meanwhile, the geocentric worldview persisted. Earth was believed to occupy the center of the universe, as if Protagoras' phrase, "Man is the measure of all things," had been realized in cosmic design. All revolved around us, the sun, moon, stars. The night sky, strewn with billions of lights, seemed an unmoving canopy. The planet Earth appeared an immobile foundation, while only certain lights moved along their mysterious paths. When mathematics became more precise, astronomers attempted to describe these movements. The great Eudoxus of Cnidus in the 4th century BCE developed a model of rotating spheres. He believed each celestial body was fixed to a sphere, and that all these spheres rotated around the Earth. For the moon, he proposed 3 spheres. 1. Completing a full rotation in a day, another every 18.6 years, and a third every 27.3 days. Combined, these spheres approximated the observed lunar motion quite accurately. From a kinematic standpoint, argued historian Żytomierski later, it did not matter whether it was the Earth moving around the Sun or vice versa. The distance between them remained constant. Eudoxus's contemporary, Heraclides Ponticus, also sought to explain the mysteries of planetary motion. He noticed that Venus and Mercury never strayed far from the Sun, and concluded that they orbit the Sun. This was revolutionary. Later, Hellenistic astronomy embraced this idea. Still, the Sun, Moon, and the rest of the stars continued to circle Earth. Thus was born the concept of epicycles. Aristotle, one of the greatest minds of antiquity, theoretically justified Earth's central position in his treatises. In On the Heavens he wrote, "If one throws a stone upward, it will return to the same point. Even if thrown to extraordinary heights, it still falls to Earth. Therefore, Earth must rest at the center. If it did not, how would objects know where to fall?" Step by step, the starry sky became a mirror for human hopes, fears, and contemplation. Astrology became a dream of order amid chaos, the belief that destiny was preset at birth. Although science charted its own path, the stars continued to shimmer above us, concealing unknown wonders. Aristotle further argued that the Earth must be spherical by necessity. Every part, having mass, moves downward until reaching the center. Thus emerged the worldview that placed Earth at the heart of the cosmos. This concept was named the geocentric model from the Greek gamma, Earth. It provided clear explanations for many astronomical observations. But far from all, Apollonius of Perga, a great geometer who lived in the 3rd century BCE, and the astronomer Hipparchus, who worked a century later, made attempts to refine the geocentric system. They developed the model originally proposed by Eudoxus of Cnidus, but to explain the mysterious, seemingly unnatural loops of planetary motion across the sky. They had to alter the very geometry of the cosmos. Apollonius replaced Eudoxus's. Heavy spheres with an elegant system of epicycles and deferents. That is, circles nested within circles. This system would later be perfected and brought to brilliance by Claudius Ptolemy. Hipparchus, however, took a different step. He proposed that the sun moves uniformly in a circle around the earth, but that the earth itself is offset from the center of this circle. This allowed him to explain the uneven lengths of the seasons. From his observations, he determined that spring lasts about 94 days, summer 92, autumn 88, and winter about 90 days. Thus was born the idea of eccentricity, a deviation from the center, which allowed the theory to be reconciled with measurements. But with the planets, matters were far more complicated. Their movements, mysterious looping, changing speed and direction, could not fit into simple geometric shapes. Hipparchus was unable to solve this problem. Another man took on this task, Claudius Ptolemy, the last of the great ancient astronomers, who lived in the 2nd century CE, built a model that for centuries would stand as the pinnacle of scientific thought. He complicated the previous scheme by adding new circles and refining speeds. In Ptolemy's model, a planet moved along an epicycle, a small circle whose center revolved along a larger circle called the deferent, which surrounded the immobile Earth. This system, as noted by Russian astronomer Brashman, achieved astonishing accuracy. Ptolemy's model dominated astronomy for 1.5 millennia. It was refined, adjusted, and pushed to absurdity by the 15th century, describing the motions of the sun, moon, and 5 known planets required 77 circles. The system became increasingly cumbersome, and more thinkers began to doubt. Was this worldview too complicated? Among the skeptics was the Polish astronomer Nicolaus Copernicus. He lived in a pivotal era, the late 15th and early 16th centuries. Reading the works of philosophers, he searched for traces of another truth, and he found, among ancient references, hints of a different system, in which the earth, like the planets, revolves around the sun. He believed that in this way, the picture would become simpler, more logical, and more elegant. Thus was born the heliocentric model. In his main work, On the Revolutions of the Celestial Spheres, Copernicus described a system where the number of circles was drastically reduced to 34. His model explained the apparent movement of the sun across the sky, and although initially it was not more accurate than Ptolemy's, it contained the seed of a revolution. It changed humanity's very view of its place in the universe. Then came Galileo, Kepler, Newton. But long before Copernicus and Ptolemy, another idea lived on, strange and captivating. Counter-Earth, anti-Earth. It was sought not in other star systems, but nearby, on the same orbit as our Earth, but on the opposite side of the sun. If it exists, it is always hidden by the solar light. This was an idea beautiful in its elusiveness. Imagine a planet orbiting synchronously with us, only 2 astronomical units away, but forever concealed behind the sun. Earth-based telescopes could not see it. With the advent of space exploration, it became clear such a planet does not exist. But the idea lived on for a long time. Even in the 5th century BCE, the philosopher Philolaus, a student of Pythagoras, spoke about it. He pictured the universe as a kind of temple, at the center of which burns the fire, a sacred hearth. The earth, moon, sun, and stars revolve around it. The earth is not a sphere, but a disk, turned on one side away from the central fire. On the side where no light reaches, reigns emptiness. And between them, anti-earth. This idea was not merely a whim. The Pythagoreans believed in the sacred. Number 10, perfect, embracing nature. But there were only 9 visible celestial spheres. So they added a 10th, invisible, the counter-Earth. Aristotle, who critically approached these theories, explained the appearance of counter-Earth as an attempt to preserve numerical harmony, even at the cost of imagination. Much later, in the 18th century, the French mathematician Joseph Louis Lagrange discovered equilibrium points in the Sun-Earth system. These special positions, where gravitational forces balance, were named Lagrange points. Among them is point L3, located on the opposite side of the Sun, exactly on Earth's orbit. Logically, a second Earth could be hidden there, but Lagrange's calculations were idealized. They did not account for the influence of other planets, and although weakly, they alter the equilibrium. Theoretically, two planets on the same orbit could not coexist. They would inevitably collide. Does this mean that the idea of anti-Earth is merely a myth? Possibly. But do myths not live in our consciousness far longer than facts? When the Middle Ages replaced antiquity, the cosmological ideas of Plato and Aristotle were inherited in a new religious context. A special role was played by Plato's dialogue Timaeus, in which the Creator God makes the cosmos as a living, perfect being, a sphere made of spheres, a whole made of wholes. Later, the works of Aristotle and Ptolemy returned to Europe. They presented the world as a rational unity, orderly, logical, explained without miracles. Their system inspired awe and corresponded to the spirit of the Middle Ages, which sought order, harmony, and purpose in the cosmos. Thus, the concept of the universe was formed, from guesses about the sacred fire to calculations of celestial mechanics. But even today, looking into the bottomless depths of the night sky, we still hear echoes of ancient voices, the voices of those who sought the center of the world and themselves within it. The sphere of the saints and the righteous is beyond earthly reach. It is there that the kingdom of God was located, his bright abode, where celestial beings dwell, angels, archangels, cherubim, seraphim, those who eternally raise a joyful praise to his name. Janus, the eternal cycle of celestial bodies, encompasses the lesser spheres like a fiery whirlwind, shining like a sword in the sky. It lifts human vision and mind to the limits of possible understanding. For there, beyond the visible, is the abode of blessed souls, an eternal haven for the high and pure spirits. This is the divine realm, where they taste a happiness unknown to us, who live in a world of vanity. However, to imagine it, one may resort to a metaphor. Imagine hundreds of people simultaneously see the same dream, and upon waking, each tries to describe it without knowing about the others. Their descriptions are fragmented and disconnected. Yet, when combined, something common can be discerned. In the same way, medieval thinkers left us many images and features of the cosmos, those that revealed themselves to them through reading ancient authors, mystical contemplations, works, and prayers. Thus, the Anglo-Saxon chronicler Bede the Venerable, who lived between 672 and 735, describes a universe in which only 7 celestial spheres exist. He does not follow ancient models, but the Bible. And yet, as French historian Jacques Le Goff rightly noted, the influence of antiquity is clearly felt in Bede's cosmology, even in terminology. Directly above the earth extends the sphere of air. Above that, the ether, and then the sphere he calls Olympus. Why Olympus? Because within it move the planets named after Greek gods. Above these nearer spheres burns a fire, celestial, pure, sometimes manifesting itself as a reminder of its presence to people. In the Middle Ages, it was believed that this was the heavenly fire. Still higher is the vault of stars, immovable and unchanging. Above them, the heaven of angels, the dwelling of holy light. This is the 7th heaven, where, according to Christian teaching, the Holy Trinity dwells. Bede's cosmology is especially interesting in how it reflects the perception of the universe by an educated person of the 6th century, a combination of biblical imagery and the still living breath of pagan astronomy. The Christianization of the cosmos continued in the works of Honorius Augustodunensis. He distinguished only three heavens: the corporeal, that which we see; the spiritual, the abode of angels; and the intellectual, where the blessed souls behold God. In the 13th century, the treatise on the sphere appeared, written around 1230. It became the standard astronomy textbook almost until the 10th century. Its author accepted the order of spheres used by Aristotle. Following the moon, he places Mercury, then Venus, then the Sun, and other planets. This was exactly how they were depicted during the Renaissance era. Thomas Aquinas, 1225 to 1274, returned once again to the ancient authorities and referred to Pythagoras, asserting that there are 10 spheres moving in the heavens. Of these, 9 are visible, 7 move the planets, the 8th governs the fixed stars, and the 9th governs the phenomenon of day. The 10th, however, is immovable and is the first cause, the prime mover of all. Dante Alighieri, 1265 to 1321, created his poetic model of the cosmos, constructing it from 9 spheres. He combined the crystalline heaven and the heaven of the prime mover, and regarded the empyrean, the heavens of God, as a separate, highest reality. If one attempts to describe what today we might call the near-Earth space in medieval understanding, it was arranged thus. Between the Earth and the Moon lay the 4 elements: fire, air, water, and earth. They were arranged in layers, in order of their specific weight. At the center was Earth, surrounded by water, above it air, and still higher, extending up to the Moon's orbit, was the celestial fire. Medieval theologians saw in this structure a confirmation of the Bible, the verse about the firmament resting between 2 waters. And God called the firmament heaven. But everything changed at the end of the 15th century. Giordano Bruno, philosopher and poet, was the first to speak openly about the imperfection of the celestial spheres. Before him, even Copernicus and Kepler believed that the cosmos was bounded by the sphere of fixed stars. Bruno proclaimed, "The universe is infinite. All stars are suns like ours, around which planets revolve, and these worlds might be inhabited by intelligent beings unlike." Use bold words. Almost a century and a half before Bruno, similarly daring ideas were expressed by Nicholas of Cusa, Filippo Faccioni, the closest advisor to Pope Pius II. He asserted that the universe has no boundaries. It is like a divine machine whose center is everywhere and its circumference nowhere. God is both center and periphery, for he is everywhere and nowhere. But Bruno's speech was the final chord. The celestial spheres fell once and for all. The cosmos became boundless. The world where angels moved planets disappeared. The universe itself was freed, but by freeing, it consumed its own herald. Bruno did not await a cardinal. He awaited the stake. He was burned as a heretic. This occurred in the age of Cervantes. And Shakespeare, at the time when Kepler and Galileo were already approaching the truth with telescopes in their hands. In 1588, Tycho Brahe, the famous Danish astronomer, attempted to reconcile 2 conflicting worldviews, Ptolemy's geocentric and Copernicus's heliocentric. He created his own intermediate model, combining the best features of both. The story began in November 1577, when a bright comet appeared in the sky. People, frightened, expected disasters. But for Brahe, those 3 months of brilliance were a time of revelation. The comet pierced the celestial spheres, which, according to former views, were solid and eternal. But it flew without breaking, disrupting ideas about the harmony of the world. Suddenly, Tycho realized the old models were imperfect. He rejected Ptolemy's excessive system of epicycles, but also found Copernicus's system unconvincing, as he could not observe the annual parallax of stars. Is it possible, he wrote to his assistant, that the stars are so gigantic if even their apparent diameter equals a minute, and they are situated at monstrous distances? It seemed impossible to him. Thus, Copernicus might be mistaken, and so he created his system. The Earth remains at the center. The planets revolve around the sun, and the sun itself moves around the Earth with them. This was a mathematically precise model, kinematically, equivalent to Copernicus's. It could even be used for predictions, as was later done with the phases of Venus. But Brahe's system, despite its elegance, did not play a major role in the history of science. It remained a bridge between worlds, one of which was already fading, and the other only awakening. Thus, the celestial spheres fell one after another, like transparent shells. But with them went an era when the cosmos was not a soulless mechanism, but a place where meanings, souls, angels resided. And perhaps, in this loss, there is something more than scientific progress. Unlike Aristotle, Tycho Brahe did not consider the sun to be the center of the world, but neither did he deny its importance. He sought a compromise between ancient order and new revelations. In his model, the Earth remained immobile, standing at the center of the universe as before. Around it revolved the moon and the sun, but the planets themselves, according to Brahe, revolved not around the Earth, around the sun. This was a transitional model, a delicate balance between tradition and boldness. In it, the sun was not the absolute center, but the center of motion, the heart of the planetary dance. But in the works of his student, Johannes Kepler, this idea unexpectedly transformed. For Kepler, the sun was no longer merely the center of the scheme. It became the source, the beginning, the mover of the celestial world. It did not just illuminate, it acted. It called forth. Kepler did not believe in crystalline spheres, in invisible gears supposedly carrying planets around in perfect mechanical harmony. All that seemed to him a beautiful but lifeless construction. He sensed that the cause of motion lay deeper, not in abstract pursuits of the perfect circle, not in immutable forms. He felt before him was a living world, a cosmos that not only exists, but breathes. And at the center of this breathing was the sun, not a silent luminary, but the sovereign heart of the world. It was not merely located in the center, it ruled. It was the beginning of motion. Through its rotation, Kepler thought, it seemed to pull the planets after it, not by means of pushes or mechanics. No, it was something else, something he could not put into words, yet it existed. He felt it. He saw its effect. What was this force? Today, we speak of it with almost indifferent certainty. Planets move along their orbits because they are acted upon by the force of gravity. This seems obvious to us. We know the formulas, the laws, the familiar diagrams. But once, this was a daring intuition, a revelation. And the name for this revelation was given only by Newton, decades after Kepler's death. Newton was the first to describe this force, to give it form, to give it words. But long before Newton, in the complete silence of the starry sky, Kepler already heard its breath. He did not know its name, but he knew its presence. He knew something emanates from the sun, invisible but tangible, like an inner impulse, like a will, a force governed not by formula, but by lawfulness. He could not express it in numbers, because such numbers did not yet exist. He could not inscribe it into geometry, because geometry did not yet know such curves. But he felt. The sun does not merely shine. It lives. It moves. He tried to imagine. What could it be? A magnet? Why not? Is not a magnet capable of influencing iron without touching it? Do not iron filings obey its invisible will? Perhaps Kepler pondered, the sun is something similar, a cosmic magnet, and the planets are but particles of stardust carried along. By its mighty attraction. He did not know how to measure this force. He did not know its law. But he saw the planets are not chaotic. Their motion is not disorder, but music. They obey a rhythm. They follow an unknown order, which he could not yet express, but felt with all his mind, with all his soul. And therefore, he was frighteningly close to the truth. He did not know the formula, but in his eyes already shone the law. He did not draw equations, but his mind already heard the harmony of the universe. Kepler was closer than he himself realized. In the 17th century, interest in the mysterious magnetic force rapidly increased. In the year 1600, the work of the English physicist William Gilbert was published on the magnet, magnetic bodies, and the great magnet, the Earth. In it, he summarized all that humanity had accumulated over centuries of observations and research. These facts inspired the philosopher René Descartes. In his Principles of Philosophy, published in 1644, he proposed that nature contains a special, subtle, almost imperceptible magnetic substance. It supposedly explains many of the phenomena occurring around us. Descartes' idea did not arise out of nowhere. By that time, Johannes Kepler had already dared to apply something akin to magnetic force to explain the greatest celestial phenomenon, the motion of the planets in their orbits. He was a diligent reader of Gilbert's book, and the description of the magnet's action seemed suspiciously similar to what was happening in the heavens. This became the key. Kepler wrote, "There exists a certain divine force." In his book Harmonices Mundi, The Harmony of the World, published in 1619, he asserted, "The sun is the moving soul. It, like a ray, transmits its influence to the planets, urging them to move along certain orbits. Not merely radiation, but a force embedded in the very motion, like a bowstring launching an arrow, or a foot pushing a pedal." This was a revolutionary hypothesis. At that time, almost no one believed that any force could act over such immense cosmic distances. And yet Kepler insisted, the intensity of this force diminishes with distance from the sun. Just like light, it grows dimmer the further you move away from its source. So it is with the soul of the mover. The further the planet, the weaker its motion, the weaker the impulse. Around the year 1600, Kepler began to use in his letters the expressions force of the mover and capacity for motion. Later, he increasingly called it the soul. He did not mean a metaphysical soul, but precisely a force, invisible, but real. Although he was mistaken in believing it to be magnetic in nature, Kepler nevertheless described celestial mechanics in the language of the physics of his time. And although today his soul of the mover is considered a scientific myth, it was a plausible myth. Paradoxically, this very myth gave the world genuine scientific discoveries. Its ideas about the interaction of planets led to the very laws of Kepler, which later became the foundation for Newton. Newton proved that two bodies, say, the sun and any planet, indeed attract each other, but not due to some kind of soul, rather through gravity. The force was no longer a metaphor, but a physical reality. And so, centuries later, in the autumn of 2015, physicists recorded gravitational waves for the first time. In 2017, the Nobel Prize was awarded for this discovery. Gravity, as Kepler had suspected, does indeed propagate. Two theories, the rejected and the accepted, myth and truth, intersect once again. Truth is incomplete without myth. And here arises another question. Did the planet Phaethon exist? This hypothesis was believed for a long time. It was believed in with the participation of science itself. The first to speak of it was none other than Kepler himself. In 1596, he drew attention to the vast gap between the orbits of Mars and Jupiter, a void that disturbed the harmony. The search for a pattern in the arrangement of planets led him to think something was missing there. In 1766, The German mathematician and astronomer Johann Titius proposed an empirical rule. If one takes the numerical sequence 0, 1, 2, 4, 8, 16, 32, multiplies each number by 0.3, and adds 0.4, and the resulting sequence is 0.4, 0.7, 1, 1.6, 2.8, 5.2, 10. These values, with astonishing accuracy, correspond to the distances from the Sun to the planets known at that time. This law gained wide recognition thanks to the work of Johann Elert Bode, and today we know it as the Titius-Bode rule. Yet, at the place between Mars and Jupiter, there was still no planet, but the law demanded that one be there. In 1781, Uranus was discovered. It fit perfectly into the numerical sequence. This reinforced faith in the law. And on January 1st, 1801, the long-awaited discovery, the astronomer Piazzi found Ceres, a small planet, seemingly hiding between Mars and Jupiter, but the joy was quickly overshadowed. Soon, Pallas, Juno, Vesta were discovered. The German astronomer Heinrich Wilhelm Olbers suggested that these were fragments of a once existing planet. Possibly it had resembled Earth, perhaps with an atmosphere, life, civilization, ... The planet was given a mythical name, Phaethon, in honor of the ancient Greek youth, son of Helios. When he tried to drive the chariot of the sun, he lost control, and Zeus, saving the Earth, destroyed him with a thunderbolt. Later, some researchers even considered the destruction of Phaethon a historical event. Its debris became moons of other planets, collided with their rings, and some even escaped into deep space. According to one hypothesis, one of the comets became Venus, another became Pluto. In the 20th century, Emanuel Velikovsky even claimed that Earth suffered from these collisions. It was knocked off its orbit. Catastrophes occurred, volcanoes, floods, climate changes. Only around the 8th century BCE, in his opinion, gravity finally stabilized the solar system. But over time, the legend began to unravel. Verification did not confirm the hypothesis. Later calculations showed there was no planet between Mars and Jupiter, only numerous small bodies, the asteroid belt. Since 1983, the name Phaethon has been given to one of the asteroids, but it does not even belong to the main belt. Scientists tried to estimate the mass of the missing planet. The French astronomer Hervé Leverrier calculated how the gravity of asteroids influenced Mars' orbit. It turned out that the combined mass of these bodies did not exceed 1/10 of Earth's mass. Modern scientists believe this is an overestimation. The real mass is closer to that of the Moon. Most likely, a full-fledged planet simply could not form in this part of the system. The enormous Jupiter, having formed, gathered all the material, leaving only fragments behind. And yet, in past centuries, scientists depicted Phaethon as a full-fledged planet, between life and death, between a possible biosphere and cold emptiness. Some believed that another civilization might have arisen there and perished. All of this sounds like a fairy tale, but a fairy tale hiding logic, the logic of searching, the logic of assumptions, the logic of hypothesis, the logic of science itself. For a long time, Venus remained a true mystery to humanity. A dense cloud veil, like a silky cover, securely hid its surface from earthly telescopes. It had neither dark seas nor red spots like other planets, nothing to catch the eye. Scientists could not even determine its rotation period precisely. Some believed Venus was always turned to the Sun with the same side. Only in the 1960s was this mystery revealed. A day on Venus, almost an eternity. It lasts 243 times longer than an Earth day. Why does it rotate so slowly? According to one hypothesis, a massive satellite once orbited nearby. Its powerful tidal forces, like giant invisible hands, slowed the planet's rotation, heating it internally. This lasted a short time by cosmic standards, only a few 100 million years. Then the satellite disappeared. Perhaps it was the size of Mercury. It moved away and left Venus to spin as we see today. But another hypothesis is even more mysterious. In 2006, Alex Alemi and David Stevenson from the California Institute of Technology suggested that Venus once collided with a massive celestial body. It shattered, and from the debris, a satellite formed. But then Venus began rotating backward, and its satellite, contrary to logic, did not move away like the moon from Earth, but approached it until it crashed onto the planet's surface. Unfortunately, confirming this hypothesis is impossible now. Venus's intense volcanic activity has erased all traces of ancient catastrophes from its surface. But did Venus have something like a moon? Possibly, yes. In 1672, Giovanni Domenico Cassini, director of the Paris Observatory and Italian astronomer, first noticed a strange object near Venus. At first, he did not believe his eyes and did not publish the data. But 14 years later, he saw the same thing again and recorded the observation. He thought the satellite was quite large. Its mass was only 4 times less than Venus itself. Then, in 1740, the same object was observed by English astronomer James Short. Later, German Andreas Meyer in 1759. And finally, in 1761, Joseph Louis Lagrange. He even reported that the satellite's orbit was perpendicular to the ecliptic, unusual and inexplicable. 1761 turned out to be special. Venus transited the Sun's disk, a rare event when Earth, Venus, and the Sun align. This happens once every 100 years or so, repeats after 8 years, then requires another century of waiting. During this transit, the Russian scientist Mikhail Lomonosov discovered Venus's atmosphere. At the same time, 5 astronomers reported observing Venus's satellite. A small dark spot accompanied it as it moved across the solar disk. However, others, like Samuel Dan, saw nothing of the sort. A few years later. In 1764, the satellite was allegedly observed by 2 more astronomers. But in 1766, Pater Maximilian Hell, director of the Vienna Observatory, suggested that all these observations were optical illusions. Venus is too bright, and its image could have been reflected inside the telescope or even inside the observer's eye, an illusion created by light and expectation. Yet, some did not give up. In 1777, German astronomer Johann Heinrich Lambert, one of the founders of photometry, measured the brightness, light intensity, and even proposed a model of the satellite's motion. He believed the object was 66.5 Venus radii away, approximately the distance between Earth and the Moon. However, his calculated orbital period was 11 days and 3 hours, which did not correspond to the distance. In 1884, Belgian astronomer Jean-Charles Azot proposed a radical explanation. Perhaps this was not a satellite at all, but an independent planet. Its orbit coincides with Venus's, and every 2.96 years it approaches Venus, creating the illusion of a satellite. Azot named this mysterious planet Neith, after the ancient Egyptian goddess of the invisible. But 3 years later, the Belgian Academy of Sciences conducted a large-scale investigation. It turned out that all observations of Venus's satellite were actually stars that happened to be near Venus in the celestial sphere at the right moment. Even James Short probably saw just a star, not an object near the planet. Nevertheless, the mysteries continued. In 1892, Edward Emerson Barnard, an American astronomer who discovered the Horsehead Nebula, noticed an object near Venus with a brightness of the 7th magnitude. There should have been no star there. What he saw remains unknown. Perhaps an asteroid passing by? Or a distant supernova flash? If so, why did no one else see it? In 2002, astronomers observed another strange object, asteroid 2002, VE68. It orbits the Sun, but does so in a remarkable resonance with Venus, making 1 revolution per Venusian year. Almost like a satellite, but not quite. Stories of mysterious. Satellites are not limited to Venus. Earth seemingly has only 1 moon. But some claimed there was a second dot. It all began on March 21, 1846. The director of the Toulouse Observatory, Frederick Petty, reported that his staff had observed an extremely small satellite of Earth. It orbited our planet, moving to an apogee of 3,570 kilometers and at perigee, nearly touching the atmosphere. Just 114 kilometers from the surface. Later, Jules Verne picked up the idea. In his novel Around the Moon, the second moon played an important role. The protagonists collided with it, altering their trajectory and returning home. Fantasy? Perhaps. But interest in this idea was rekindled. In 1898, Georg Walter of Hamburg claimed to have discovered a whole system of Earth satellites. One of them, he said, was 700 kilometers in diameter. He asserted that sometimes this satellite was mistaken for the Sun. Citing polar explorer Adolf Greely, he claimed that the latter observed the solar disk for 10 consecutive days after the onset of polar night. On February 4, 1898, dozens of observers gathered in the German town of Wald. They watched the Sun, awaiting the passage of the second moon. A certain spot did move across the solar disk, and yet 2 experienced astronomers, Winkler and Baron Ivo von Benko, were observing simultaneously and saw nothing unusual. American astronomer William Henry Pickering published calculations in 1903. If the second moon had a diameter of 3 meters and was 320 kilometers away, it could be seen with the naked eye. If we do not see it, then it is either very small or does not exist at all. Nevertheless, the idea persisted. Pickering in 1922 devoted a new article specifically to the second moon, describing how and where could be sought. And in 1926, a German amateur astronomer claimed to have observed a satellite crossing the moon's disk. In the 20th century, even astrologers joined the discussion. The idea of the black moon Lilith appeared, a mysterious object, invisible to instruments. Some believed it had a mass equal to the moon and appeared only when passing across the solar disk. Perhaps indeed, each time someone discovered the second moon, they only saw a temporary satellite. Earth sometimes captures small asteroids that become its satellites for days or weeks and then disappear. In 2019, Canadian astronomer Paul Weir noticed asteroid 3753. Its orbit is strikingly similar to Earth's. It does not orbit Earth directly, but moves with it in synchrony, like a shadow, like a satellite that does not belong, and yet follows closely. Our planet is surrounded by many mysteries. Some dissolve in sunlight, others vanish into the depths of time. But every generation once again lifts its gaze to the sky, hoping to catch sight of something unusual, something elusive, and still waiting for its moment.